Section 7.3, multiplying and dividing rational expressions. Okay. Our objective for this lesson is to simplify, multiply, and divide rational expressions. The process is very similar to rational numbers. Okay. So we're going to always go back to that rational number idea, but first we need to discuss what is a rational expression. Our book's definition is it is a fraction whose numerator and denominator are non-zero polynomials. Basically, a rational expression is the division of two polynomials. Okay, and we write it as a polynomial over another polynomial, very similar to our rational functions. Okay, so we're going to take one polynomial, our p of x, and divide it by another polynomial, a q of x. Okay. So this section we're going to be simplifying, multiplying, and dividing them. Hopefully then with our, from there then we'll go into solving them and doing some other stuff with these rational expressions. But first, what does it mean to have a rational expression in simplified form? What does it mean to have something in simplified form? Let's go back and let's look at a fraction, just a plain old fraction in simplified form. Let's look at the fraction 4/8. This is not in simplified form because the numerator and the denominator have a common factor. They have a common factor. Again, a factor is something that you multiply to get to it. That's from a multiply. They have a common factor, so we will divide out that common factor to get to a fraction of 1/2. 1/2 would be the simplified because it has, the numerator and denominator have no common factors other than 1. Okay, have no common factors other than 1. 1 is a common factor of every number. Dividing by 1 isn't going to get us anywhere. So when it comes to simplifying a rational expression, really to simplify a rational expression, you divide out the common factors. That's how we're going to simplify a rational expression. For example, if I had a times c divided by b times c. Again, this is a multiply, a times c. So a and c are both factors because there's a multiply in between. And b times c. I can divide out c divided by c and get 1, and I'm left with just a over b. We divide out those common factors. Again, a really important word there is common factors. You cannot divide out things unless they are factors, unless you multiply to get to them, which means we're going to be factoring a lot today. So we're going to be doing a lot of factoring. Okay. So we're going to have to do a lot of factoring first. So I need to have things factored before I can simplify them. So here in example 1. X squared minus 4x minus 12. These are not factors because they are subtracting in between or adding a negative on how you want to think about it. So I can't just cross out the x squared and the x squared and the 4 and the 4 because those aren't factors. I need to factor the numerator, factor the denominator first, and then look for those common factors. Okay, so if I factor the numerator, let's see, let's factor this guy. So this is going to factor. Well, multiplies to give me x squared, that's x and x. I'm just guessing and checking here. Well, multiplies to give me negative 12. When I add, I get negative 4. I'm believing negative 6 and positive 2. Okay, so when these are my two factors. X minus 6 is a factor and x plus 2 is a factor. Now let's factor my denominator. X squared minus 4. Well, this is a difference of two squares, so this is going to factor into x plus 2. X minus 2. If we multiply that out, we'd have x squared minus 2x plus 2x. That cancels. Minus 4. So now, our first step was to factor the numerator and denominator. Now look for common factors. Okay. So when I look here for my common factors, x plus 2 is a factor in both the numerator and denominator, so they will divide out to 1. So then I'm left with x minus 6 over x minus 2. You cannot cancel the x's here. They are not factors. Hey, that's as silly as saying, like our 1/2 here. Well, I could rewrite that as 1 over, well, 1/2 is 1 plus 1. That's 2. And dividing out the ones and the ones and just getting 1. Well, we know 1 and 1/2 are not the same thing. This does not work. You cannot cancel things unless they are factors. So this is how it simplifies. Except we have one extra thing to take into consideration here. We need to check our domain. Because if I look at these, let's look at both of these in our calculator. Let's look at the original and let's look at the factored. Okay, so let's go to my y equals, let's graph this. So to graph this, I need to distinguish between my numerator and denominator. So I'm going to have to put the whole numerator in parentheses. So I'll have x squared minus 4x minus 12. I'm taking that whole thing and dividing it by this denominator whole thing. So I need that in parentheses too. X squared minus 4, parentheses. So numerator and denominator both all in parentheses. Okay, and let's graph the simplified one. Again, numerator all needs to be in parentheses, x minus 6. So taking that whole thing and dividing it by that whole thing, x minus 2, parentheses, x minus 2. And if we look at a table of values here, let's type in 1, we get the same thing. When we type in 2, we get an error. Why is that? Well, if you look at both of these, when I put a 2 into this and a 2 into this, I get a 0 in our denominator. And we already discussed you can't divide by 0. Hey, but look what happens when I put a negative 2 in. In the first one, I get an error. In the second one, I don't. I get a 2. That's because in this first equation, I could put a negative 2 in. In the second one, I cannot. Because if you notice, this factor here, this x plus 2 that we divided out, okay, gives me, when I put a negative 2 in this factor, I get 0. So these two are exactly the same except at negative 2. So I need to denote that in my answer because I cannot put a negative 2 into this thing because I couldn't put a negative 2 into the first one. So x cannot equal negative 2 because that was the factor that I canceled out. So you always need to check your domain when simplifying or even multiplying and dividing these rational expressions. Because these two agree, these two things are the same thing everywhere except at negative 2. Because negative 2 was the factor, the 0 that I canceled out. So you need to take that into consideration. So this whole thing would be my answer. X cannot equal negative 2. I can't put a negative 2 into this. Because I can't put a negative 2 into that. Because when I put a negative 2 into the first one, I get an error. So that tells me I can't put a negative 2 into the simplified one either. For them to be equal everywhere. Okay. All right, so let's multiply rational expressions. Well, you multiply rational expressions just like you multiply fractions. If I'm multiplying a fraction, a over b times c over d, we just multiply straight across. a times c over b times d. That's what we do here. We just multiply straight across. Okay. But a lot of times it's easier to actually simplify before actually doing all the multiplying. Okay. So here an example 2. Okay, so I'm going to multiply straight across, but I'm just going to write it as a multiply. 8 times x to the third times y times 7 times x to the fourth times y to the third. I just multiplied these two things, but I didn't actually multiply them in. Okay, and then here I have 2 times x times y to the second times 4 times y. Now we need to simplify. Well, the simplifying is a whole lot easier by doing it this way. Well, let's see, let's look at the number parts. I have 8 times 7 and 2 times 4. 2 times 4 is 8. So 8 divided by 8 is 1. So then all I'm left with is a 7. So I have my 7 in the numerator. Let's distinguish numerator and denominator. Now let's look at my x's. So here, we can put our x's together. So I'd have x to the, I have 4 here and 3 here, so that'd be x to the 7th. And then y to the 4th. All over, I'm just looking at the variables here, x, y to the 3rd, 1, 2, 3. Okay. So then now, if we look at dividing, this is x to the 1, we subtract my exponents. 7 minus 1 is 6, so I'll have an x to the 6th. And again, there's more of in the numerator, so it's going to be in the numerator. y to the fourth minus y to the third, well, it's just going to be y to the 1. Well, so there. I don't have anything in my denominator anymore. So I just have 7x to the 6th y. But then we always have to check your domain. In this one, I can't put an x 0, and I can't put a y 0 because it makes my denominator 0. So I need to add x cannot be 0 and y cannot be 0. You always have to check your domain. Check your denominators. And by check your domain, I mean look at the denominators. The denominator cannot be 0. Okay. All right. Let's look at multiplying another rational expression. But here I have some adding and subtracting. So I could distribute this all in and make a really long, complicated thing. But I know eventually I'm going to have to simplify it. And to simplify it, I'm going to need it factored. So let's factor everything first. So out of this numerator, I can factor out a 3x. And I'm left with 1 minus x. When I took a 3x out of that, I get 1. If I take a 3x out of that, I'm just left with 1x. Okay. All over, and now let's factor this denominator. We'd have an x and an x plus 5 minus 1 times, and then now let's do the same thing. Let's factor this one. X and an x. Let's see, multiply to give me negative 20, add to get 1. That'd be 5 and 4 plus 5 minus 4. And all over a 3x down here. So when I multiply these, I'll just have one big long fraction with a multiply in between. So now again, we want to look for common factors. So again, we factored, and then now we want to look for common factors. So what factors do I have in common? Well, I have an x plus 5 in common. That divides out to give me 0. So that tells me what makes that 0? A negative 5. So this tells me that x cannot equal negative 5 because I canceled that factor out. And then I also have factor 3x. Well, what makes 3x 0? That's 0, so x also cannot be 0. So I'm going to take that in consideration with my answer. And then, so now what do I have left? X minus 1, 1 minus x, and x minus 1, and an x minus 4. So I'd have a 1 minus x and an x minus 4 over an x minus 1. These two things are the same, except for this one is opposite sign. Here the one's positive, here the one's negative, here the x is negative, here the x is positive. So if I take a negative 1 out of that, so let's take a negative 1 out of it. I'm kind of out of room, so I'm going to come over here. If I take a negative 1 out of it, I'll be left with negative 1 plus x. So I'm just taking a negative out of this thing right here, all over x minus 1. Well, now these are the same, negative x, so those will divide out also. So what makes that 0 is 1, so also x cannot equal 1. Well, what am I left with? Just a negative out front and x minus 4? So I'm left with a negative out front and x minus 4. So here's my simplified answer, negative x minus 4, which we could distribute that in, and we'd end up with 4 minus x. And then x cannot equal negative 5, cannot equal 0, and cannot equal 1. So there is my whole final simplified answer. So I get 4 minus x can't equal negative 5, x can't equal 0, and x can't equal 1. Because of the factors I canceled. So again, notice, as I canceled those factors, I noted what made them 0. Okay, because that's, those are numbers that I can't put into this. So if I was to try, if I was to try this original function right here, in my calculator, type this whole thing in, if I was to put in a negative 5, I'd get undefined. If I was to put in a 0, I'd get an undefined. If I was to put in 1, I'd get undefined. So those are the numbers that I can't put into this, because I could put a 0 into this and get 4, but that's not what I get when I put a 0 into that, and we want these two things to be the same. Okay, let's get another one. Okay, multiplying a rational expression by a polynomial. Well, just think of this as over 1. So then you treat it the exact same way, except it's a fraction with a denominator of 1. So again, we factor, this is x plus 2. Now to factor x cubed minus 7. That's a difference of cubes. Okay, so we're going to need to know our difference of cubes. Okay, our difference of cubed, if I have a cubed minus b cubed, that's the same as taking a minus b times a squared. Now change my sign, plus ab. Last one's always plus b squared. Ooh, kind of out of room there. Okay. So my a in this case is x. My b in this case is 3, because 3 cubed is 27. So this is going to factor into x minus 3 times x squared. Change my sign, plus, now multiply the 2, 3 times x, plus, now square the 3, 9. And that's going to equal x squared plus, times, not equal, plus 3x plus 9 all over 1. Well, now if you notice here, I don't even have to worry about factoring this, well, because it doesn't factor. These actually now will divide out. Now, so we canceled something out, so now we have to think about, does that mean I have to put an x is not equal to something? Well, we need to look, does this thing ever equal 0? Does x squared plus 3x plus 9 ever equal 0 for any real number? Well, if we're not sure, we can always graph this. Graph our x squared plus 3x plus 9 and look to see, is it ever 0? Nope, it's always up here. It never crosses the x-axis, so it's never 0. Nope, it's not ever 0, so I don't have to worry about it. So x plus 2 over x minus 3. And there's how we finish it. Okay. Dividing rational expressions is very similar to multiplying rational expressions, and it's exactly like dividing just fractions in general. If I have a over b divided by c over d, I just multiply the a over b times the reciprocal. So you just multiply by the reciprocal. So that's going to be your very first step in all of these problems, is to basically just rewrite the problem, but with the flip. So if I want to take 7x over 2x minus 10 and divide it by this, it's the same as multiplying by the reciprocal. So I write my problem down, and then I multiply and I flip it. All I did is wrote that as my divide as a multiply, and then flip these two things. Now I do it just like I did my previous examples. Okay, I factor. Well, 7x can't be factored. 2x, I can factor out a 2 out of that. It's minus 5. Okay, now in this numerator, let's see, x and x. Multiply is going to be 30, add I get negative 11, 6 and 5, negative 6, negative 5. And out of this is only 2 terms, x squared minus, factor out an x. X and x minus 6, okay. Now we can divide out common factors. Well, I can divide out my x minus 6's, so that means that x cannot equal 6. Divide out my x minus 5, so that tells me that x cannot equal 5. And then anything, I can divide out the x's. So x cannot equal 0. So what am I left with? 7 over 2? 7 over 2. So this always equals 7 over 2. But x cannot equal 6, 5, or 0. Okay. That's interesting. It just equaled a whole number. So when I divide these, I actually just get a number. All right, let's do another one. We're dividing a rational expression by a polynomial. We do it just like our multiply one. We put it over 1. But before we go to factoring, we need to switch this to a multiply problem. So we'll have 6x squared plus x minus 15 all over 4x squared times 1 all over 3x squared plus 5x. Okay. Now we factor. Okay. So we need to factor 6x squared plus x minus 15. My leading coefficient isn't 1, So this complicates things a little bit. So I'm going to factor it off to the side, and I'm going to use organized factoring. For those that don't remember, we take the 6 times the negative 15. We get negative 90. And I want to know what numbers multiply to give me negative 90, add I get 1. Got 1 and 90, 2 and 45. Those are still way too far apart for me to add them. I get really big numbers. 9 and 10. If the 9 is negative, when I add them, I get the 1. So now I rewrite this. So I'm doing this my factoring off to the side. So now I'm going to rewrite this as minus 9x plus 10x minus 15. Now I group the first two with still a plus in between. Group the next two. Again, there's still a plus in between. Out of these, I can factor out a 3 and an x. Of these, I can factor out a 5. Now, if you notice, they both have a 2x minus 3 in common, so that's one of my factors. My other factor is what's left, 3x plus 5. Okay. All over 4x squared times 1 all over. Out of these, I can factor out a x. Is it? And I'm left with 3x. Well, so my 3x plus 5's cancel. So as I cancel that, I have to think what makes that 0. What makes 3x plus 5 0? Subtract the 5. Divide by 3. When x is negative 5/3, so x cannot equal negative 5/3. And what else? Anything else cancel? I don't think so. 2x minus 3. So my numerator is 2x minus 3. My denominator is 4x to the, I've got 2 there, 1 there, 4x to the 3rd. And x cannot equal negative 5/3. Again, be careful. A lot of people just start canceling the 2x's and the 4x cubed. This 2x is not a factor. The 2x minus 3 is, so you cannot cancel those. Okay. All right. Okay, now on the back side here we have some extra practice. I don't want you to do all of them. I want you to do, let's do number 1 and number 4. Do those two. And then do number 5, number 8, and number 10. Do those, and there should be room to do them here. If not, you can grab another sheet of paper. So 1 and 4, 5, 8, and 10. Come to class ready to discuss.